We had looked at several applications of the PSR-SPSC concepts, including the potential for mining of phosphorus by growing plants. In this lecture, we look at phosphorus storage and release in tree-based agricultural systems and with corresponding treeless systems. Here is what is termed as a silvopastoral system. You have trees and you have an area in between which is grasses. So we looked at different types of silvopastoral systems. One is a planted silvopasture and the other is a native silvopasture, which is simply native vegetation. And we compared that to treeless pastures. Treeless pastures were there before the silvopastures were planted. Here are the location of the study plots. You have the pasture, a Silvopasture 1 and a Silvopasture 2, and then a Silvopasture 3. The Silvopasture 1 is, well, it's a silvopasture, and it differs from Silvopasture 2 in that Silvopasture 2 was thinned. That means some of the trees were removed. And Silvopasture 3 is simply the native vegetation in the silvopasture. And finally, we have an open pasture or pasture without any trees, and these were the areas where the comparisons of SPSC were made. Soil sampling. We sampled by depth 0 to 5, 5 to 15, 15 to 30, 30 to 50, 50 to 75, and 75 to 100 centimeters at 26 locations between trees in a silvopasture and 26 locations in the alley of the silvopasture. In addition, we sampled the soils at 26 locations within the treeless pasture and 10 locations between trees in the native silvopasture and 10 locations in the alley of the native silvopasture. The soil test that we did in all was Malic 1P, Malic 1 iron, and aluminum were determined in each of the soil sample. The silvopastoral system consisted of slash pine and bahia grass, and the open pasture was simply the pasture without trees. Let us look at the SPSC for the silvopasture under the trees. The soil P storage capacity is in the x-axis and the depth in the y-axis, as we have seen in previous slides as well. Here the soil P storage capacity is calculated in terms of P, kilograms of P per hectare per centimeter depth for each of the different depths. Note, this is a spodosol with a BH horizon occurring approximately 30.3 centimeters. What we notice here is that the SPSC is positive throughout, all right? And how positive it is depends on the depth. You will notice that it's highest at the BH horizon. And now we look at the silvopasture and compare the SPSC with that of an adjacent treeless pastures. This time we are looking at the silvopasture at the center of the alley, and of course the open pasture is the one to the bottom right hand side. Now for the silvopasture with the tree in it, the tree component, you will notice again it's very similar to the one that we looked at earlier. That is, you will find SPSC to be positive throughout the profile. And the BH here occurs at about 30.7 centimeter depth. Finally, if we take a look at the treeless pasture, what you notice is the treeless pasture, the storage capacity is much less than that of the tree-based pasture. Obviously, the storage capacity has been compromised by phosphorus moving down the soil profile. And a look at the surface horizon, the 0 to 5 centimeter depth, also shows that this is an area where the surface horizon has been compromised, or that it has negative capacity at this point. If you look at the storage capacity, the x-axis are the same for the two graphs, and you'll notice comparable or lots of differences in the storage capacity between the two systems. We know now that the soil pH storage capacity can be calculated to a meter depth or any depth that we desire, and this is exactly what we did for the various land use systems that you have here. The Silvopasture 1 is with 494 trees per hectare. The Silvopasture 2 is thin silvopasture with 309 trees per hectare, and SP3 is the native silvopasture. What is termed as pasture is simply the treeless pasture. What we notice that to 1 centimeter depth, it's very different for the pasture compared to the silvopastures, in that the pasture has got less remaining capacity to store P. However, this capacity is still positive, so that in this case, up to a meter depth, there is still some capacity even for the pasture to receive additional phosphorus. We look now at SPSC at 4 other silvopastoral sites. And what we do find here, what we have looked at, are both spodosols and altisols, and the locations are indicated in the maps. They are from 2 from the Suwannee County, both of which are altisols, and then we have a private ranch in the Osceola County, spodosols, and a private ranch in Manatee County, which is also comprised of spodosols. You know the difference between how spodosol profile looks and the altisols looks, and it's depicted once again in this particular slide. The study sites, at each of these sites we had silvopasture and an adjacent treeless pasture. That's true for both the spodosols and the altisols. What we find now is the differences between the two treatments, that is silvopasture and treeless pasture, in the Alachua and Suwannee counties, as well as the Manatee and Osceola counties, all to a meter depth. If you look at it carefully, for the Alachua County, which is again on an altisol, the SPSC is negative for both the silvopasture and the treeless pasture, suggesting that these soils here are P sources. When we look at the Suwannee County, the silvopasture and the treeless pasture has negative capacity, whereas the tree-based pasture has positive capacity. So it's likely that more phosphorus can be added to the silvopasture in the Suwannee County versus that in the treeless pastures. For the two spodosols, we have a different scenario. In the Manatee County, you have silvopasture, which is positive in both this for the silvopasture and the treeless pasture, and the same is true for the Osceola County. And here, therefore, although the values themselves look higher, that is, the storage ability is higher in the silvopastures, it is not statistically significant in the soils in that particular Osceola County. Remember here, it is not just a comparison between soils. The silvopastures have been there under various periods of time as well. A younger silvopasture and the treeless pasture are less likely to have a problem compared to one which is an older silvopasture. We now look at water-soluble P at the 4 locations. The water-soluble P here is depicted on the x-axis with depth on the y-axis. Your left-hand figure is for sporosols and that of the right hand is for altisols. Broken lines in both represent treeless pastures, whereas firm lines represent the silvopastures. In the left-hand side, the firm line, the red ones, stand for Osceola, and the blue ones for the Manatee County. They have a slightly different location for the BH horizon. On the right side is the same thing for altisols. What you have here is this firm line, the Silvopasture, that is the red is for the Alachua and the blue is for the Swanee. And of course the corresponding red and blue stands for the treeless pasture in Alachua and Swanee counties. In general, tree-based systems, that is silvopastures, have less water-soluble peat throughout the soil profile, corresponding to increased silvopasture compared to adjacent treeless pastures. So in summary, we note that SPSC can be used to evaluate peat storage under treeless and tree-based agricultural systems. In most cases, SPSC is greater under tree-based systems compared to treeless systems to a specified depth. And P release as measured by water-soluble P is greater in systems where there are no trees. So simply, in effect, under trees, you have a greater SPSC, greater potential for storing P compared to that of a treeless systems. And also we note that there is no more water-soluble P in systems where there are no trees. This is simply another method of showing phytoremediation or removal of nutrients, in this case phosphorus, by the trees in these systems. And finally, we have a few references that are directly related to this particular topic.